Okay, today we're learning about linear systems, the last lesson in this chapter. Linear systems is simply math language to describe two or more equations considered at the same time. To get started, let's just look at this warm-up question. Last day I asked you to look at two coordinates and to find the equation of the line that passes through those two coordinates. And then in the second question, you also used your graphing display calculator to confirm that is indeed the answer. Here, well, today you're also going to check your answer using your GDC on your own, but I'm going to walk you through just one more time how to calculate the slope of a line or the equation of a line using just two coordinates that the line passes through. So of course we always want to start off with our slope formula, y2 minus y1 over x2 minus x1. In this case, y2 minus y1 is going to be 10 minus 3, and 6 minus negative 2 is really 6 plus 2. If we follow our integer laws. 10 minus 3 is 7, and 6 plus 2 is 8, so our slope is 7/8. So we know that right now y equal 7/8 x plus b. But we don't know the y-intercept. We know there are an infinite number of lines that can have the slope 7/8 or have a slope of 7/8, but we don't know exactly which y-intercept we're talking about because we can have, for example, um, let's see, we can start at 0, 0 and go up 7, right 8, up 7, right 8, and up 7, right 8, and we'll have something like that. We'll have an infinite number of lines that have that slope, but there could be multiple y-intercepts. Depends which line we're talking about, which one of those lines we're talking about. And in this case, we're talking about the line that actually passes through both coordinates, negative 2, 3, and q 6, 10. So let's sub in one of those two coordinates to solve for b, so we can find out exactly the trajectory that that line is on and where it will cross the y-intercept. Remember that you want to sub in. I'm going to use the coordinate 2, 3. So remember to plug in the proper part of the coordinate, right? We're tempted sometimes to write the negative 2 first because it comes first in the coordinate, but we have to remember that we're subbing in the y value of that coordinate. In this case, the y value is 3. So equals 7/8 and times, in this case, negative 2, and then plus b. And we can do, oh, that's good. So we'll have now 3 equal, now you may recall the cross reducing strategy, so I can technically cross reduce negative 2 and the 8. Negative 2 divided by 2 is negative 1, and negative 8, 8 divided by 2 is 4. So I can cross reduce, and then I'm left with 3 equal negative 7/4 plus b. And if that confused you, let me just show you something else here. What we could have done, if you'd like, if that makes more sense to you, we could have just done 3 equals 7/8 times negative 2 plus b, and we say 3 equal 7 times negative 2 is negative 14, and 8 times the imaginary denominator of 1 is 8 plus b, and then you'd have 3 equal, and if you reduce negative 14 over 8, you'd get negative 7/4. So that's really what we did, but we saved ourselves that reducing process. We saved ourselves of having to reduce later on by cross-reducing right here. So that's why now I have 3 equal negative 7/4 and then plus b. I want to solve for b, so we're going to add 7/4 to both sides. So 3 plus 7/4 equal b, and then the common denominator here will be 4. So we have, what do we do to the imaginary 1 here? To get to 4, we multiply by 4, and then 3 times 4, of course, is 12. So we have 12/4 plus 7/4 equal b, and we get 19/4 equal b. Therefore, we have y equal 7/8 x plus 19/4. That's our answer for that. You could check that with your graphing display calculator. Now I want to move on. Again, solving a linear system, the main goal of this lesson. To solve a linear system means to find the point of intersection. If you're finding the point of intersection, that point, you'll notice here in the learning goals, that point of intersection must satisfy both equations. And that's just math language to let you know that where the point of intersection occurs, if you look there, these two lines cross at the point of intersection of 3, -3. That means that that coordinate 3, -3 must be on both lines. It has to be on the blue line and the red line. So in order to confirm that, what we must do is sub that coordinate into both equations to make sure that it satisfies, or that left side equal right side. And I'll show you what I mean in a second. Let's first just look at how I graph these in the first place. The y equal -x, that is, of course, direct variation because there is no plus b in that equation. It's just y equal -x. And we know that it's really y equal -1x. So the slope is really -1. If I start at 0, 0, I can go, if it's -1, I know that's really -1 over 1. So I go down 1, right 1, down 1, right 1. I can also go up 1, left 1, up 1, left 1 from that origin and graph my line. I'll erase that just so we can see more clearly. Then I also have the red line. Let me just erase that. The red line. And of course here I started at the -6. If I start at -6 here, then I go, my slope is 1, which is really 1 over 1. And then I go up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1, down 1, left 1. And I get that. And I notice that both those lines intersect at 3, -3. And then what I want to do is to double check that that indeed is the case. If the point of intersection is 3, -3, then I'm going to take both of those equations, y equal -x and y equal x minus 6, and I've done that down here for you. Y equal -x and y equal x minus 6. I've got both those. And we're going to sub in 3, -3 into both. So if I sub -3 in for y and negative x, or -1 times x here, I get -3 equal -3. And of course, -3 should equal -3, or we say here left side is equal to right side. We're going to do the same thing for this equation. Sub in -3 for y and sub in 3 for x. And I get -3 equal, and 3 minus 6 equal -3. So all we did is sub in -3 for y and the 3 in for x. And we realized that left side equal right side. If that's the case, when you sub that coordinate into each of those two equations and find out that left side is equal to right side, you've now confirmed that that is indeed the point of intersection of those two lines. If you have a mistake here, it's a good checkpoint. If you have a mistake here, then you know you've definitely made an error either in drawing your lines. You may have found the wrong point of intersection. You need to go back to the drawing board and see perhaps which line you graphed incorrectly. We're going to do the same thing. You might want to pause the video here and try letter B on your own. So let's take a look at that. Again, I've color coordinated this in blue and red. So the blue line, the first one, I just threw a little bit of a wrench in the gears here for you. So basically, it's written in standard form, a little bit more difficult, but nothing crazy. So we just rewrite that equation. You'll notice I rewrote that equation down here, x plus 2y minus 4 equals 0. I left the 2y on its own here, and as you'll see in purple, we subtracted x from both sides, or what it looks like is that x is going over to the other side. Okay, and then we also did the same thing with the -4. It went over to the other side. And of course, when you switch sides, change signs. So we end up with 2y equal -x plus 4 in that second step. Then we divided both sides by 2, and we ended up with y equal -1/2 x plus 2. Or, I just wrote this to remind you of good form. Another way of writing -1/2 x is -x divided by 2, or negative x over 2. Because you may see that sometimes you'll get an equation written in that format, but it really means -1/2 x. Or again, there's two ways of writing that. In graphing this line, I started with the y-intercept of +2, and of course, then I looked at my slope, -1/2, and I just from that point, from the point +2, went down 1 right 2, down 1, right 2. And then I also went up 1, left 2, up 1, left 2. And either way will get you that line, right? Okay, and for the red line, a little simpler, I had a y-intercept of positive 5. That's pretty simple. And the slope is 1. So if I start at positive 5, the only tricky part with that one right here, you'll notice I'm at the top end of my grid. And I don't want to go off the Cartesian coordinate system and graphing my line. I don't want to keep graphing my line from that point and going up 1, right 1, up 1, right 1. Now I'm off the grid, which sounds nice environmentally speaking, but doesn't work so well with Cartesian coordinate systems. I don't want to be off the grid here. So I know that the slope is 1, or 1 over 1, but I also know that that slope is the same thing as saying negative 1 divided by negative 1, because negative divided by negative is positive. So those two slopes are technically the same. And so if I'm given a y-intercept right there at the top of my grid, I can then go down 1, left 1, and down 1, left 1, and keep repeating that pattern. And that's how I graphed this line this time. All right. Okay. Now once I graph those two lines, I realize the point of intersection is negative 2, 3. And so I want to check my answer as the question asks us to do. Check our answer. So I've wrote the equations, both equations, check 1, check 2, and I'm going to sub in negative 2, 3 for both. So let's sub in negative 2 for x here. So we have negative 2 plus 2 times, and y in this case is 3 minus 4 equals 0. And here we'll sub in y is 3 equal negative 2 plus 5. And I'm just going to do one line at a time. So I have negative 2 plus 6 minus 4 equals 0. And then this is negative 2, negative 2 plus 6 is positive 4, minus 4 is 0. So I get 0 equals 0, or left side equal right side. Here I have 3 equal negative 2 plus 5, and negative 2 plus 5, as you know, is 3. So I also have left side equal right side, and check, check. That works for both. Therefore, I've confirmed that that point, negative 2, 3, is indeed definitely the point of intersection. What I want you to do as well is to use your graphing display calculator to solve this linear system. And I've given you a hint here. You want to use the y equal function of your calculator, enter both equations, and then find the point of intersection, or POI for short, which is the solution to a linear system. And let me erase that there. The solution to a linear system, and you'll see that's in the learning goals. The solution to a linear system is the point of intersection. And the intersecting point must satisfy both equations. So in checking your answer by subbing in that coordinate into both equations, you are confirming that indeed left side equal right side, or that that coordinate is on that line. Okay, that is it for today. See you in class.